A very brief introduction to sketching with force. We will cover what I mean by sketching with force, and then two example apps, TopOpt, which gives us good organic curved shapes, and LayOpt, which gives us trusses, building frames, and things made of small straight pieces put together. What do I mean by sketching with force? Sketching, so 2D, not 3D. Take 30 seconds to make the example, repeat it 5 times, test lots of ideas. The idea is that if something is carrying more force, it gets thicker, which is the same as trees, and the results tend to be quite organic and quite nice looking. Optimization is moving towards perfectly balanced forces, but that's the enemy. We don't want to do that. We don't want to get trapped in this endless loop of moving things 1 millimeter to see if it gives us that 1% improvement. We're looking for inspiration here. So we'll start with an example. The Qatar National Convention Centre, which has this lovely, sinuous, organic form at the front of it. Taking one half of that front, we're just going to simplify it down to a 2D problem. So we're going to say that there's weight coming in from the roof at those 5 points. We're going to put supports at the bottom, and then we're just going to run a mesh across it, analyze it. Where those squares are picking up force, we keep them. If they're not picking up enough force, we delete them. If they're picking up too much force, we put extra back in. This takes 99 lines of MATLAB code. Oh, and that was the first result. This is running it on my phone, so the resolution is quite low. But as you can see, I've got the loads in, I've got the supports in, but it's suggesting actually I want this big arch over the top of the center. Now I don't want that. I want to emphasize that low flat shape. So I'm going to put in some constraints, and it solved it almost instantly, but the result is now too solid to actually make out the details. So what I need to do is go to the cog and just dial down the black to white ratio. And the result is, yeah, fairly close, fairly close. It's missing one extra strut on that central point there. But apart from that, yeah, that would be enough for me to start drawing and sketching out shapes, I think, for the next stage of design. And that's all it needs to do. It's not a perfect shape. And you can generate those, but they're only valid for that specific design case. If you need to move the roof beam later to accommodate, I don't know, a stairwell or a ventilation hatch, then that arrow where that roof beam is pressing down is moved and you get a new shape would be made. Very small changes can cause big ripples. And the other bit is that this is designing to express the forces in the structure. But 99% of the time, the structure is designed for the worst possible combination of things all happening at once. And it might happen once in that structure's life. Is that the thing you want to express? Or are you trying to express the everyday case, but you still need to actually be strong enough to carry that emergency case? So there are limits to this approach, and that's why I'm advocating it as inspiration, not necessarily solution. A quick example, I was interested in a tree-shaped column. The supports are in the same place, the loads are in the same place. I changed the direction of the loads by about half a degree, and it gave me a completely different solution. So you do have to be very careful. You can't take that this is the one true solution. The other app I wanted to demonstrate is LayOpt. This isn't an app on the phone. This is a browser-based one, but it works very similarly, and it's very, very intuitive to use. It doesn't work on a grid mesh system. It works by putting nodes throughout the space, connecting all those nodes up to all of them, each other, and then getting rid of the elements that aren't doing much. And the result is quite efficient, and it tends to bring the same patterns forward, as you will see. So for that same Qatar NCC problem, the loads, the supports, none of this is measured. This is all 30-second sketches, but it gives us a completely different solution. And that would give you a very different looking front of building. Not necessarily worse, not necessarily better, but different. We have a nice tension arc across the top, keeping everything tight together. And then these blue lines are the compression arcs carrying those loads up. And we have a second tension arc here to keep this stable because there's slightly more load on this side than on this side. This was one I generated myself. This is if you've got a reasonably tall building under very heavy wind load, you've got very strong pressure on one side, you've got very strong suction on the other, and you have a twist as that wind pressure changes as it goes over the roof. But the resultant framing is beautiful. I would love to have that on an office building. If you go taller and thinner and you keep it balanced and symmetrical, then you move away from that classic zigzag or X-frame bracing, and it moves closer to this very sort of Gothic shape. And I would like to see this used. So it's like the other, just inspiring structures. So the above, there is a standard truss, which if rationalized comes in at about half the weight, which is a huge saving in steel and a huge saving on your building if you're saving that weight on every floor. The other example here is for a new type of suspension bridge where the pylon is split. So instead of having one big vertical mast, you have multiple ones at angles to allow the forces to flow around the corners in a approximating closer to a circle. It might well double spans we can get on long span bridges. Speaking of bridges, quick example. Again, this is because it started off as a 2D solver. It's very easy to do a 2D bridge, and it's a very simple example that people can look at and use. It cost the same to manufacture, but you do need to be able to accommodate and manage that complexity. There's more to check, and there's more joints to detail and drawings to pass out. So the automation on this course is going to be partly about managing that. Further reading, I've got a link to the underlying code for both. I've got a link to the tutorial for both, and also a link to the Grasshopper add-in if that is where you want to go and you want to push it into something a little bit more heavy duty and not just sketching with force. Thank you.